All right, so after that last section on that long division with polynomials, we might think, oh, there's got to be an easier way to do division, and there is. We have this process called synthetic division that is a shortcut to doing long division, and it only works in certain circumstances. You can only use this if you're dividing a polynomial, so it has to be a polynomial with degree 1, so it has to have at least an x, but usually an x squared, an x to the third, fourth, fifth power. And you can only use it when you're dividing by x minus some number, and it could be something like x minus 4, x minus 1/2, or it could even be x plus a number. Okay, so remember, x minus a number, this could be x minus -1. All right, so if we think about this in terms of looking for factors or zeros, because we will be looking for those, you can only use it if you have a binomial and then just a number here that we can easily find a zero of. You can't use this if you wanted to divide, let's say, by x squared minus 1. So you cannot use it for that. You can't use it if you wanted to divide by a trinomial. Okay, so that won't work. It just has to be in the form of x minus something. So this is how this works. I'm dividing by this number, which is x plus 1, and I want to find the 0. I'm going to only look at the 0, so if I set this equal to 0, I get x equals -1. So that's the number I'm going to divide by, and I'm going to write this number over here, and then I'm going to make this little chart. In this polynomial, I have an x to the third power, second power, first power, and then a constant. I'm only going to write my coefficients of those numbers. So my coefficient of x to the third is 1, and then I have a positive 2, then I have a -3, and then I have a positive 1. So first thing I'm going to do is bring down that first number. Okay, first number automatically just drops down. Now I'm going to multiply. -1 times 1 is -1, and I'll add the numbers down. So 2 plus -1 is +1. Then I'll multiply. -1 times 1 is -1, and then I'll add down. -3 plus -1 is -4. -1 times -4 is +5. I'm sorry, is +4. I'm getting ahead of myself here. And 1 plus 4 is 5. So then what we're going to do is we're going to look at this last number as being our remainder. This number is going to be our constant, and this is the coefficient that we're going to use. This number will be the coefficient of the x to the first term, and this number will be the coefficient of x squared. So I can say that my answer is 1x squared plus 1x to the first power minus 4 plus my remainder, which is 5, over the number I'm dividing by, which is back here, which is x plus 1. Okay, a lot easier on that using synthetic division. All right, so the next problem, I'm going to first identify my 0. So my 0 is x is -2. Okay, if I set this equal to 0, my 0 is -2. I'll use -2, and then I will make my chart using my coefficients. So first I'll check my exponents. 3, 2, 1, 0. Constant is x to the 0. So I'll write my coefficients, which is -4, 2, -1, and 1. I'll bring down that first one, which is -4. -2 times -4 is +8. And then I'll bring down 2 plus 8 is 10. -2 times 10 is -20. And then I'll add these, and I'll get -1 plus -20 is -21. -2 times -21 is +42. And I'll add that down and get 43. So this is my remainder. This is my constant. This is my x to the first power and my x to the second power. So if I say how many times does x plus 2 go into this polynomial, I have -4x squared plus 10x minus 21 with a remainder of 43 over x plus 2. Much simpler than long division. In part B here, I'm going to divide by x minus 2, so my 0 is 2. So in my chart, I'm going to start with 0, or start with a 2. And looking at my exponents, I have 4, I'm missing a 3, I have a 2, I'm missing a 1, so I have 0x third here, and then I have a 0 x to the first power here, and I have to include those coefficients. Again, I'm holding my place for those values. So my coefficients are 1x to the fourth, 0x to the third, 1x squared, 0x to the first, and 2 as my constant. I will start the process by always bringing down that first number. So I have a 1 here. So I have 2 times 1 is 2, and I add down. 0 plus 2 is 2. 2 times 2 is 4. Add down, I get 5. 2 times 5 is 10. Add down, I get 10. And 2 times 10 is 20, and I get 22. Oops, 22. 22 is my remainder. Constant, x to the first, x squared, x to the third. So my answer, and I do want you to write this out. I don't want you to leave it for me to determine what that is, what you intend it to be. So this is 1x to the third plus 2x squared plus 5x plus 10 with a remainder of 22. And it's not over 2, it's over what we're dividing by, which is x minus 2. Moving along. Got a couple more examples quick here. So here I'm dividing x to the fifth minus 1 by x minus 1. If I identify my 0 is 1. And I have a lot of places to hold here when I am writing down my coefficients. So I'm starting with x to the 5, which is 1. I have 0x to the fourth, 0x to the third, 0x to the second, 0x to the first, and then minus 1 is my constant. So fifth, fourth, third, second, first, constant. So I'll bring this down here. I have a 1 times 1 is 1. Add down, I get a 1 again. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 0 plus 1 is 1. 1 plus 1 is 1. 0 plus 1 is 1. I keep repeating this. 1 times 1 is 1. Now I'm going to add -1 times 1 is 0. So this time I have no remainder. Here's my constant, x squared, x third, x 4. So my answer is 1x to the 4th plus 1x to the 3rd plus 1x squared plus 1x plus 1 and no remainder. Okay, so one thing I want to make note of here, and every time we've done the division, I start with an x to the 5th power. In my answer, we always drop down one exponent. So my answer will include an x to the 4th. I'm just going to kind of point that out here. I started with an x to the 3rd power, and this is from the page before. My answer is 1 less than that power, which was 4x squared. Okay, and that's something that we should always look for. So one last one, I have my 0 is 1. So I'm going to divide again by 1. So here my coefficients, I have a 6, I'm missing a 5, and a 3, and a 1. So I'm missing my odd exponents. So I'm going to start with 4x to the 6th, 0x to the 5th, negative 3x to the 4th, 0x to the 3rd, 1x squared, 0x, and then a 5. All right, so repeat the process. Bring down the first number, which is 4. 1 times 4 is 4. Add down, I get 4. 1 times 4 is 4. Add down, now I get 1. 1 times 1 is 1. Add down, I get 1. 1 times 1 is 1. Add down, I get 2. 1 times 2 is 2. Add down, I get 2. And 1 times 2 is 2. Add down, I get 7. So my remainder is 7. This is my constant, x1, x2, x3, x4, x5. And it should be x to the 5th power because it is 1 less than what we started. So my answer is, 4x to the 5th plus 4x to the 4th plus 1x to the 3rd plus x squared plus 2x plus 2, and I'm going to add my remainder, which is 7 over x minus 1. It's a long one. Okay, so one thing that we can use synthetic division for is to determine if something is a factor. And if something is a factor, we're going to get a remainder 0. So looking back in example C, notice that we got a remainder 0, and because of the remainder 0, I can say that x minus 1 is a factor of x to the 5th minus 1 because I divided this in and got remainder 0. So that's one thing that we can use synthetic division for, is to test to see or to verify if one number is a factor of another. So in example 3, it says to show that x plus 3 is a factor of this polynomial. All right, so we're going to use synthetic division. Here my 0 is negative 3. So I'm going to start with negative 3 and write my coefficients and just check my variables. I have a 5, a 4, a 3, a 2, a 1, and a 0. So I have all of those from the 5th power down to the 0 power. My coefficients are 2, 5, negative 2, positive 2, negative 2, and 3. I'll bring down that first number, which is 2. Negative 3 times 2 is negative 6. Add these down, I get negative 1. Negative 3 times 1 is positive 3. Add these down, I get 1. Negative 3 times 1 is negative 3. 2 plus negative 3 is negative 1. Negative 3 times negative 1 is positive 3. Add down, I get positive 1. And negative 3 times 1 is negative 3. And add down, I get 0. And this 0 is my remainder. And because I get remainder 0, I know, therefore, x plus 3 is a factor of that polynomial. I'm not going to rewrite the whole thing, but yes, x plus 3 is a factor because of the remainder 0.